Hey kiddos, this is Miss Wendt again. And so in the last video, we kind of made a mess of this worksheet, and that's totally cool. The new thing I want to show you on it is this little piece right here, how to figure valence electrons. So valence electrons are the electrons in just the outside energy level. So it says count the number of electrons on the outermost energy level. And I kind of showed you there's a pattern to this with what group it's in. So on your little charts here, everything in group 1 had one valence electron. So I could put a little 1 here. This would also be a 1, and so would the 1 at the bottom here. Everything in group 2 would have 2 valence electrons. Everything in group 3 would have 3. Everything here would have 4, so forth, so forth, so forth. And then this outside group here would have 8. And 8's kind of a magic number. Atoms are happy when that outside energy level is full. So if you have a full energy level of 8, you are happy. Now, all of the things, all the atoms in this group 18 are happy with 8 electrons. But there's one kind of little weirdo to the group, and that's this helium up here. Helium does not have 8 valence electrons. And the reason is this little energy level can only hold 2. But those 2 electrons, that does fill this up. That little energy level only holds 2. So I'm going to say there's only 2 valence electrons, but I'm going to kind of put a little star there. It is full with 2, so he is happy that way. Even though all the other atoms need 8 to be happy, he's happy with just 2. Now that means that all of these other atoms on the periodic table, all this stuff, is not happy right now. And in the next chapter, we're going to figure out how to make them happy. But there's a few skills we got to get first before we can get there. Okay? So group 18, these guys are happy just the way they are. It's like just chilling on the couch, nobody bugging them, just happy the way they are. These guys are not happy yet. They either want something or they want to lose something, and we're going to get them happy later. Okay? So that's all we're going to do with this page. And you probably have a bunch of blanks on these boxes. Don't care. That's fine. The most important thing on here is figuring out these patterns between the groups and the periods with how many energy levels they have and with how many valence electrons there are. All right, so I'm going to shift you ahead to the next page. It looks like this. Okay. And let me kind of scroll this down a touch for you. So what this is this is another example of us people in science is we're just lazy. I do not want to draw all that nonsense for every atom. All those circles and dots are silly. When really the only dots we're concerned about, the only electrons we care about are the ones in the outside. Okay, so this is called a Lewis structure. Lots of teachers will call it right here, it's called a dot diagram. And it's a simplified, so a simple and easy way to show the valence electrons in the outer shell. And this is going to be important for making these atoms happy in the next unit. Okay? So using your periodic table, determine the number of valence electrons for each element. Well, you sort of have that one we just drew all over that's going to be real helpful here. And we're just going to draw a dot to represent these guys. So I know that in this group number 1, let's see, instead of using my keyboard, let me try the pen here again. Much better, even if it's 2 different colors. So this is all group number 1. These guys are all going to have 1 valence electron. So the Lewis dot structure would just be the symbol with 1 dot to show 1 valence electron. These guys are in group number 2. These guys would have 2 dots. Now you might be wondering, does it matter where I put the dots? Well, here's kind of a little pattern here that most teachers follow. In real life, Mrs. Wendt does not care what order you put the dots in. But if you'd like a pattern, here's one you can follow. Group 3 has 3 dots. 1, 2, 3, 1, 2, 3. Group 4 is going to have 4, 5, 6, 7, and so forth. And this guy over here, this neon, is happy with 8. I'm going to put a little smiley face there, because he's happy with his 8 electrons. Now remember, helium doesn't have 8. It's only going to have 2 because of that fact that it only has that one little energy level and it only holds 2. But it is a full energy level, so this guy is happy. Okay, so what I'd like you to do is fill in the dots for the rest of these guys, just following our pattern. Group 1, 2, 3, 4, 5, 6, 7, and 8. And remember on the periodic table, this is actually group 1, group 2, and then it skips a bunch of stuff. 13, 14, 15, 16, 17, 18. Okay, so go ahead and pause the video, fill in those dots, and then you're ready to move on. All right, the next page here has some information that you're going to read and answer some questions about. It talks about the energy levels you already know about, so that's a nice review. Okay, talks about valence electrons, which we just learned about on those Lewis dot diagrams. And then down here, this might be some new info for you. It says protons, neutrons, and electrons are not the only subatomic particles, so pieces that are smaller than atoms. These major particles are made up of smaller particles called quarks. But it is the behavior of hungry outer shell electrons as they try to balance positive charges of protons in the nucleus that results in chemistry. Blah, blah, blah. Okay, so we do have these little things called quarks. We're not really going to worry about them. These outside shell electrons are going to be the most important parts of the atom for us going forward. The neutrons and protons and those inside electrons just kind of sit there and hang out. These outside ones move around and do cool stuff. Okay, so after you've kind of reread this, keep in mind this page number has nothing to do with any of your stuff. You'll fill in these answers here, and here's kind of a sneak peek of some answers, and you can pause that if you'd like to. And I'm going to move on here. So this page, I'm not going to do this whole page for you, but I will help you get started. You are going to need a periodic table. So go ahead and dig one of those out or look in the back inside cover of any physical science book. And we're going to figure out some stuff for each atom. Okay, now if I look at the periodic table for this element named calcium, there's going to be 2 numbers there. I'm going to see that it has atomic number of 20, if my pen wants to work correctly, which apparently it doesn't. There we go. Atomic number 20, and it has a mass of 40. So you have done some work. We can figure out how many protons and neutrons, electrons that has, and that's pretty cool. So if I do a diagram of this, like I said, I'm pretty lazy. I am not going to draw a circle for every proton and electron. I'm just going to say, hey, in the center of this atom, come on, pen. All right, in the center of this atom, technology is awesome. All right, let's try this pen thing again. So if I do a picture of a calcium atom here, it's going to have 20, seriously. Let's try my finger. It's going to have 20 protons in the middle, and it's also going to have 20 neutrons because it has a mass of 20. Okay, and it's going to have some energy levels, and I don't have room to do full circles, but I know in the first energy level there's going to be 2 electrons. In the second energy level there's going to be 8 electrons. That gives us a total of 10. My next energy level can hold 8 more, and it's happy. And then we're going to have 2 in the next level. Okay, so when we fill in electrons, we always put 2 in the first, then 8 in the second if we have that many. If we still have some left, we can put 8 in the third level. And then after 8, the next 2 are going to go in level 4. Okay, calcium's the biggest atom we're going to worry about drawing. Okay, now because calcium is in the 4th row down on the periodic table, so if I show you, kind of go back here to our periodic table, here's calcium. Calcium is in row 1, 2, 3, 4th row down. So it has 4 energy levels of electrons, and it's also in group 2, second group over, which tells me it should have 2 valence electrons. So, and I have that. Okay, we're in the 4th period down, 4 energy levels, and I am in group 2, and I have 2 electrons in the outside. So that's kind of a nice way to double check your work. If you count and put the electrons in, it should match. The period number should match how many energy levels or circles of electrons you have, and the group number should match how many electrons are in the outside. Okay, so if I'm in group 2, I have 2 valence electrons in the outside, and if I want to do a Lewis jot of this guy, I write the symbol for calcium, and I just need 2 little dots. Pretty cool. Okay, let's look at the next one. If I look on the periodic table at carbon, I notice that the atomic number is 6 and the mass of carbon is 12. And I got those numbers off of the periodic table. You will always have the periodic table to look stuff up. You do not have to memorize it. All right, so in the center of my atom, I'm going to have 6 positive protons. And for my mass of 12 minus 6 protons, 6 minus 12 will give me 6 neutrons, so that's pretty cool. All right, so if I have 6 positive protons, I also need 6 electrons. So with that, I've got 2 electrons on the first level, and then that leaves me 4 electrons left, so 4 would go in this second level. I know it can hold 8, but it's only got 4, and that's perfectly fine. So I drew 2 energy levels. So this atom must be in period 2, and my outside level has 4 electrons, so I must be in group 4. So if I flip back to my periodic table here and double check, carbon is in group 2. I'm sorry, period 2, going down and going across. 1, 2, 3, it's the 4th one going across. So that is correct. Okay, now instead of group 4, you could write group 14. Same diff, no problem. So I have 4 valence electrons on the outside. My symbol for carbon is a C. Again, I can look that up on the periodic table. There's a big C there. And I need 4 dots to represent the 4 valence electrons. So your job now is to try to finish the rest of this page and pack it. And when you're done, have me take a look at it, or have Ms. Domingos take a look at it and see how you're doing. And then we will keep rolling from there. Thanks.